Good day, everyone. Good morning, grade 9 students. I'm Ma'am Osias, your teacher facilitator for this morning. Welcome to week 9 of quarter 1 Mathematics 9 synchronous class. The most essential learning competencies are number 1, determines the equation of a quadratic function given its table of values, graphs, and zeros. And number 2, solve word problems involving quadratic function. After going through our module, you are expected to: number 1, identify the steps in determining the equation of quadratic function. Number 2, derive the equation of the quadratic function given its table of values, graphs, and zeros. And number 3, solve word problems involving quadratic function. Before we will proceed to our lesson, let's start with a short review. As we all know, quadratic functions can be written in general form. F of x is equal to ax squared plus bx plus c, and can be written or transformed into vertex form. F of x is equal to a times the square root of x minus h plus k, or vice versa. Remember that we have the formula for h, which is negative b over 2a. And k is equal to 4ac minus b squared all over 4a. For the review activity, what's my vertex? So using the given quadratic functions, determine the coordinates of the vertex. So the coordinates of the vertex are represented by h and k. So if the quadratic function is written in vertex form, right away you can determine the value of h. So this is negative h. So just get the opposite of the expression, the second term. The second term of the binomial squared. And for the value of k, the constant term or the term right after the binomial squared. Like for example, in this case, y is equal to 2 times the square root of x minus 1 plus 3. So the value of h is the opposite of negative 1, which is positive 1. And for k, this is the value of k. Okay, let's start with number 1. Y is equal to 3 times the square root of x plus 2 minus 1. The quadratic function is written in vertex form. So right away, you can determine the value of h and k. So the value of h is the opposite of positive 2, which is negative 2. And for k, this is negative 1. So as is. Okay, next, number 2. Y is equal to negative 2 times the square root of x plus 3 plus 5. Just like number 1, number 2 quadratic function is written in vertex form. So right away, you can determine the value of h and k without using, no need to use the formula for h and k. So the value of h is the opposite of positive 3, which is negative 3. And this is the value of k, positive 5. Number 3 quadratic function, again, the function is written in vertex form. So the value of h is the opposite of negative 2, which is positive 2. And since there is no term right after the binomial squared, so understood it is 0. For number 4, the equation or the function is written in general form. So you can use the formula for h and k. the quadratic function is written. The quadratic function is written in general form. So you can identify the value of A, which is 4. The value of B is 0 since there is no linear term. And the value of C is the constant term, which is negative 7. So using the formula for H, we have negative B over 2A. Substitute the value of B, which is 0. And for 2 times A is 4. So 0 divided by the product of 2 and 4 is equal to 0. So H is 0. And for K, you can also use the formula for K, which is 4 times A, which is 4, times C, which is negative 7, minus B squared, B is 0, divided by 4, times A, which is 4. Simplify both numerator and denominator. This is negative 112 divided by 16, which is equal to negative 7. Next, the last one, number 5. Number 5 quadratic function is written in general form. So we can use the formula for H and K. Identify A, 4. Identify B, which is negative 8. And for C is negative 21. So to determine the value of H, we use the formula negative B over 2A. So negative B is negative. Then the value of B is negative 8. So we have negative times negative 8 divided by 2 times A, which is 4. Simplify. This is 8 divided by 8, which is equal to 1. So therefore, the value of H is 1. And for K, we use the formula for AC minus B squared all over 4A. So substitute the value of A, B, and C in the formula. So this is 4 times 4. 4 times A, which is equal to 4, times C, which is equal to negative 21, divided by 4 times A, which is 4. Simplify. 4 times 4 times negative 21 minus negative 8 squared is equal to 400. Divided by the product of 4 and 4 is 16. So 400 divided by 16 is negative 21. So meaning if the quadratic function is written in vertex form, right away you can determine the value of H and K, or you can determine the vertex. And if the equation is not yet written in vertex form, you can arrange the term, or you can rewrite the quadratic function in general form, identify the value of A, B, and C, then use the formula for H and K. I will discuss lesson 1, deriving quadratic function, and lesson 2, solving problems involving quadratic function. For lesson 1, how to derive quadratic function. To derive the quadratic function means to determine the equation that will represent its table of values, graphs, and zeros. Let's have the first example. Given the table of values, how to determine the quadratic function. In deriving the quadratic functions, given the table of values, you may use the following steps. Number 1, choose any set of ordered pairs x, y from the table. I will consider negative 1, negative 3, 0, negative 2, and 1, 5. Second step, substitute the ordered pairs in the equation y is equal to ax squared plus bx plus c. For the first ordered pair, negative 1, negative 3, replacement for y is negative 3, and replacement for x is negative 1. So by substitute, we have negative 3 is equal to a times the square root of negative 1 plus b times negative 1 plus c. Simplify, negative 3 is equal to a minus b plus c. Since negative 1 squared is positive 1 times a is equal to a. And b times negative 1 is negative b. So this will be our equation 1. Equation in 3 variables. For the second ordered pair, 0, negative 2. Replacement for y is 2. Replacement for x is 0. In the equation, y is equal to ax squared plus bx plus c. Substitute. So we have negative 2 is equal to a times the square root of 0 plus b times 0 plus c. Simplify, negative 2 is equal to c because square root of 0 times a is 0. And 0 times b is 0. So we still have c. So this will be our equation 2. Actually, we already have the value of c, which is negative 2. For the third ordered pair 1 and 5, the replacement for y is 5 and for x is 1. Substitute, y is 5, x is 1, x is 1. Simplify, 5 is equal to a plus b plus c. Since 1 squared is 1 times a is a, and b times 1 is b. So this will be our equation 3. So let us rewrite equation 1, equation 2, and equation 3. Next step, solve the system of equation by elimination or substitution to find the value of a, b, and c. So we will substitute, we will use equation 2, which is c, or negative 2 is equal to c, in equation 1. In other words, we will substitute the value of c, which is negative 2. So this is negative 3 is equal to a minus b. For positive c, we have negative 2. Simplify, negative 3 plus 2 is equal to a minus b. We use addition property of equality. We add positive 2 to both sides of the equation to make positive 2 equal to 0. So 3 plus 2 is equal to negative 1 is equal to a minus b. So this will be our equation 4. So we will use, this time, we will substitute again c is equal to negative 2 or negative 2 is equal to c. This time in equation number 3. So we have 5 is equal to a plus b. Replacement for c is negative 2. So this one. Simplify. Use addition property of equality. We will add positive 2 to both sides of the equation to make negative 2 equal to 0. So this is equal to 5 plus 2 is equal to a plus b. 5 plus 2 is 7 is equal to a plus b. So this will be our equation 5. So equation 4 and equation 5 are equations in 2 variables. Next. So, okay, let us rewrite equation 4 and equation 5. This time, we will solve the system by elimination. We will eliminate variable b. So, by addition, negative 1 plus 7 is 6 is equal to 1a plus 1a is 2a. Negative b plus b is 0. So, to get the value of a, we will divide both sides of the equation by 2. 6 divided by 2 is 3. 2a divided by 2 is a. So, a is equal to 3. 3 is equal to a is the same as a is equal to 3. Since a is equal to 3, we will use a is equal to 3 in equation 4. Meaning, we will substitute the value of a, which is equal to 3. So, negative 1 is equal to 3 minus b. Since a is 3, by using addition property of equality, we will add negative 3 to both sides of the equation to make positive 3 equal to 0. So, negative 1 minus 3 is equal to negative b. Negative 1 minus 3 is negative 4 is equal to negative b. Divide both sides of the equation by negative 1 to make the coefficient of b equal to positive 1. So, 4 is equal to b. You already have c is equal to negative 2. So, there you have it. We have 3 is equal to a, 4 is equal to b, and negative 2 is equal to c. The last step is to write the equation in the form of y is equal to ax squared plus bx plus c by replacing the exact values of a, b, and c. So, y is equal to 3x squared plus 4x minus 2. Since a is equal to 3, b is equal to 4, and c is equal to negative 2. Therefore, the equation now is y is equal to 3x squared plus 4x minus 2, or f of x is equal to 3x squared plus 4x minus 2. Remember the steps in finding the equation of quadratic function given the table of values. Choose any set of ordered pairs xy from the table. Substitute the ordered pairs in the equation y is equal to ax squared plus bx plus c. Solve the system of equation by elimination or substitution to find the values of a, b, and c. And, of course, write the equation in the form of y is equal to ax squared plus bx plus c by replacing the exact values of a, b, and c. Let's have another example, this time given the graph, how to determine the quadratic function. So, this is the graph of the quadratic function. In deriving quadratic function given the graph, you may use the following steps. Number 1, determine the vertex hk and a point xy. So, V represents the vertex hk. So, this is the vertex of the graph or parabola whose coordinates are negative 1 and negative 3. So, h is negative 1, k is negative 3, and a point xy on the parabola. So, this is a point on the parabola whose coordinates are 0, negative 1, x is equal to 0, y is equal to negative 1. Next step, use the quadratic functions in the form y is equal to a times the square root of x minus h plus k to solve for a. So, replacement for y is negative 1. So, y is equal to negative 1. Write a. Replacement for x is 0. This one. And replacement for h is negative 1. And for k is negative 3. Simplify. Negative 1 is equal to a. 0 minus negative 1 is 0 plus 1 squared minus 3. Negative 1 is equal to, since 0 plus 1 is 1 and square root of 1 is 1 times a is equal to a. Just write negative 3. By using addition property of equality, add positive 3 to both sides of the equation. We have negative 1 plus 3 is equal to a. And negative 1 plus 3 is equal to 2. So, a now is equal to 2. So, let us rewrite the vertex. Negative 1, negative 3. The obtained value of a is 2. The next step, substitute the obtained value of a and the given vertex hk to the quadratic function f of x is equal to a times the square root of x minus h plus k, and simplify. So, y is equal to 2, the value of a is 2, Replacement for h is -1 and for k is -3. So y now is equal to 2 times the square root of x plus 1 minus 3. Since x minus -1 is x plus 1 squared. And plus -3 is equal to -3. So this is now the vertex form of the quadratic function. Or you can also, the last step is to express the function in general form. So the general form is y is equal to 2 times the quantity x squared plus 2x plus 1. This is the product of x plus 1 squared, right, minus 3. Next, multiply 2 to each term of the expression inside the parentheses. 2 times x squared is 2x squared. 2 times 2x is positive 4x. And 2 times 1 is positive 2. Right? -3. Simplify. 2 minus 3 is -1. So therefore, the equation is y is equal to 2x squared plus 4x minus 1. This is the general form of the equation. Remember, the steps in finding the equation of quadratic functions given the graph. First is to determine the vertex hk and a point xy. Second, use the quadratic function in the form y is equal to a times the square root of x minus h plus k to solve for a. Next is to substitute the obtained value of a and the given vertex hk to the quadratic function f of x is equal to a times the square root of x minus h plus k, and simplify. And the last one, express the function in general form. Let's have another example. This time given the zeros of quadratic function. Find the equation of a quadratic functions having 3 and 5 as zeros. In deriving quadratic functions, given the zeros, we will use the following steps. By working backward, let x is equal to 3, the first 0, and the second 0 is 5, so x is equal to 5. Equate to 0, that is x minus 3 is equal to 0, and the other one, x minus 5 is equal to 0, by using addition property of quantity. Next, write as factors. First factor is x minus 3 times the second factor, x minus 5 is equal to 0. Next, multiply the factors by using the FOIL method. X times x is x squared. X times -5 is -5x. -3 times x is -3x. And -3 times -5 is positive 15 is equal to 0. Next, express the function in general form. So, we have x squared. -5x minus 3x is equal to -8x plus 15 is equal to, let y is equal to 0. And since y is the function of x, so f of x is equal to x squared minus 8x plus 15. This is the general form of the quadratic function. And since f of x is equal to x squared minus 8x plus 15 is not unique, meaning to say there are other quadratic functions whose roots or zeros are 3 and 5. So, the equation now is f of x is equal to a quantity of x squared minus 8x plus 15, where a is a non-zero constant. So, aside from this equation, other quadratic functions whose zeros are 3 and 5 are f of x is equal to 2x squared minus 16x plus 30. we simply multiply the right-hand side of this equation by 2 or any non-zero digit. Another one, f of x is equal to 3x squared minus 24x plus 45. So in this case, we multiply 3 to x squared minus 8x plus 15. So aside from this, there are other quadratic functions whose zeros are 3 and 5. So therefore, we have f of x is equal to a quantity of x squared minus 8x plus 15, where a is a non-zero constant. Okay, next, find the equation of a quadratic function having negative 3 and 2 as zeros. So this time, we will use another method since the zeros are negative 3 and positive 2. So we will use r sub 1 and r sub 2 for the zeros. Then the equation is f of x is equal to a times x minus r sub 1 times x minus r sub 2. Substitute r sub 1 and r sub 2. R sub 1 is negative 3. R sub 2 is negative 2. Simplify. F of x is equal to a times x negative, or x minus negative 3 is x plus 3 times x minus 2. Then by using the FOIL method, f of x is equal to a, x times x is x squared, x times negative 2 is negative 2x, positive 3 times x is positive 3x, and positive 3 times negative 2 is negative 6. The equation now is f of x is equal to a quantity or times the quantity of x squared plus x, since negative 2x plus 3x is positive x. Rewrite negative 6. So where a is any non-zero constant. Okay, this time given the sum and product of the zeros. The sum of the zeros is negative 5 and the product of these zeros is 12. What is the equation of the quadratic function? So we will use the equation f of x is equal to x squared minus the sum of the roots x plus the product of the roots for the zeros. So f of x is equal to x squared minus r sub 1 plus r sub 2 are the sum of the roots, which is negative 5. So negative 5x plus r sub 1 times r sub 2 is the product of the roots, which is positive 12. Simplify. F of x is equal to x squared minus negative 5x is positive 5x plus 12. Or you can also use negative b over a for the sum of the roots, or c over a for the product of the roots. Remember, the steps in finding the equation of the quadratic functions given the zeros, by working backward, first equate to 0, next write as factors, next multiply the factors, and express the function in general form. Given the zeros, by using sum and product zeros, take the sum of the zeros, which is negative b over a. Take the product of the zeros, which is c over a. Substitute the function f of x is equal to x squared minus the sum of the zeros, x plus the product of the zeros, which is c over a.